Hang on a minute, Bob. I'm going to run outside and switch over to the vertical. I got to think of a better way to do this.
You're not drilling more holes in the wall, are you?
Okay, I guess I'm blessed in that I'm able to put up more than one HF antenna and need to be able to switch between them. But as it stands right now, I only have a 3-port switch box and I've got 4 antennas. And I wouldn't mind to have a 5th position on that switch box too for when I'm building antennas and just experimenting. It'd be nice to have a spare SO239 to plug into. So what's a boy to do? Well, obviously Swiss cheesing the wall isn't a good idea. But I think it's finally time to start on a project that I've been mulling over for quite a while, and that is an antenna switch box. So a remote box where I can control from inside the shack and have the SO239s that are being switched outside the shack. And of course, to be able to do that, what we're going to do is employ something known as a relay. And I ordered these off of Amazon. These are rated at about twice the capacity that I need as far as amperage and wattage, so they should do just fine. So what I'm thinking about doing is using 6 of them in an enclosure with a whole bunch of these SO239s. Just doing the math, we're going to need 7 of them. Okay, 7. So, 7 SO239s. 1 will be the output from the box, going to the radio, I should say the input, coming from the radio. And then these are going to go to the various antennas that are all being switched. It sounds like a plan, right? And then we'll add in one little device that I've been lacking, and that is lightning protection. So before I plug into the radio, I'm going to put a surge protector, not really a surge protector, it's more like a lightning arrestor, I guess. Yeah, lightning arrestor. That way I can ground this to my 8-foot ground rod that I have out there with some 6-gauge wire minimum, and that'll give me some much needed lightning protection. So this is all of the components that are going to be used outside. I did purchase this little box from Amazon, which should work smashingly for this. So I can arrange all these SO239s on the back panel. Let's see if there's room. Okay, so maybe we'll only have 5 switched inputs instead of 6, because it only looks like I can fit 6 SO239s in this box. And even then I might have to notch a little bit. But it will work. And just checking to make sure you can still, yeah, that'll work. Okay, so that's the plan. And I actually ordered 2 enclosures from Amazon. One of them is for the box that sits outside that does all the switching. And the other one that I ordered is for the box that's inside that does the switching. And that one disappointed me because although the picture looked big enough, this is clearly not big enough to put 6 switches in, so I'm not going to be able to use it. Although it's a nice little enclosure and I'll hang on to it. I'll find a use for it somewhere down the road. But instead I went scrounging outside and I found this, which is just an old leftover enclosure box that I had used for a different project. And actually the paint should be dry on the top lid. Let me go grab it. Whew, it's been sitting out in the sun. That is quite warm. But this will be my inside box right here. So I'm going to have toggle switches along one side. The way this is going to work is pretty straightforward with a couple of caveats, and we'll get to that right now. So essentially what I'm doing is I'm going to have a 12 volt, my camera focus. I'm going to have a 12 volt supply. My 12 volt supply is this. This is just an old power supply that I scrounged out of a drawer or a box or something. And focus is going to be a problem. So let's manual focus this real quick. Looks pretty good. Okay, so where were we? 12 volt supply. So I'm just going to hardwire this 12 volt supply to the box, but essentially what we're going to have are some switches. So we'll have 12 volts up here, and that's going to come into a row of switches. And now I mentioned that I was only going to use 5. That 6th switch will be used for something else other than switching in it to SO239. We'll get to that in a second. But anyway, we'll wire the hot side of this to all 6 switches. So these are single pole, single throw switches. All they do is make a circuit. That's it. And the other half of this circuit is going to be going to a relay. So we're going to have outside, in a separate box, we're going to have 6 relays. And all we're going to do is we're going to have the coil, all of the coils for the relays are going to be tied together. And they're the other half of our 12 volt power supply. So this is the ground side of that power supply. 12 volt and ground. 12 volt and ground. 2 leads. And then the switch side of the coil is going to come off of our 6 switches in the inside box. So this is what the primary side looks like. So you flip a switch, it applies power to a relay. Turn that switch off, turn this switch on, applies power to this relay. Turn that switch off, turn this one on, applies power to this relay, etc. Now, I've made switch boxes in the past that used rotary knobs, which works great. But I can think of at least 2 situations where you might want to turn 2 SO239s on at once. And I bet you can think of them too. But suffice to say, we're going to use toggles. Now, these relays are double pole, or no, they're single pole double throw. So they're going to have a normally closed contact and a normally open contact. When you apply power to the coil, it switches. The normally closed becomes normally open. The normally open becomes normally closed. The normally closed with power removed from this outside box. When you remove power from this, everything on the normally closed side of this relay is shunted to ground. The same ground that my lightning arrestor is going to be tied to. As I apply power to each relay in sequence, the shunted ground opens in the relay and it connects the center conductor of the SO239 to the output of our box. So whatever input we choose, by flipping the toggle switch, becomes our output. We're going to have 5 of them. And so you're probably thinking, well, what's the 6th one for? Well, the 6th one is going to be a dummy load inside the box. So the 6th position, I made up this dummy load years ago. It's 50 ohms. I think it's 50 ohms. Let's make sure. 68 ohms. Close enough. So you can make up a resistor network like this to get roughly 50 ohms to give you a high power dummy load. So you just run your resistors in parallel and in series until you get the right impedance. Not the ideal thing to do, but it's good enough for a quick power check or out of a radio. So this will be inside of this box somewhere, hopefully. Hopefully I can squeeze it in there. We'll see. If not, I'll delete it and not worry about it. But that's essentially what's going on. So you flip a switch, applies power to the relay, enables an SO239 to feed the output of our box. Turn that switch off, turn this one on. This one becomes our input to the antenna. And this is our radio. So radio input, output. Radio input, output. Radio input, output. Radio input, output. And that's all there is to it. And the only issue in design that I may see will come on higher frequency HF. And what may happen is at 30 megahertz or 29 megahertz or 54 megahertz, if I choose to run a 6-meter antenna, I might run into a situation where the box is going to add a certain amount of inductive reactance and change the SWR. And the solution for that, if I run into that, is simply to run a capacitor from the center conductor of the SO239 to ground. And you can do it on the input and the output, and it's typically very small capacitance, something on the order of 10 picofarad normally. And you just basically cancel out that inductive reactance with a little bit of capacitive reactance, and you can get it back to square one that way. I won't know if it's an issue or not until I actually build it and hook an antenna to it or a nano VNA and see if it's actually going to be a problem or not. So we got most of our materials covered. We do need to supply power and ground to the outside box from the inside box. What I've chosen to use for that, trying to remain as simple as possible, and using what materials that I have on hand, what I'm going to use is Cat6 cable. So I'm going to take one Cat6 cable, I'm going to chop it, and there's going to be a pigtail coming out of the inside box. The other half of it's going to be a pigtail coming out of the outside box. And then I have a million Cat6 cables just laying around waiting to be utilized for something like this. And I can just connect the dots with these couplers. So these couplers will be the bridge between the inside box and the outside box. Now this is an experiment. These are not waterproof. They are not sealed from the elements. I don't know how well they will work. I don't know how long they will work. But this is what we'll use to start with. And if it fails and I need to switch to something down the road, I will. I just happen to have these on hand, and therefore I'm going to use them. I ordered these for another project. They weren't needed, so I threw them in a drawer. So we'll use them now. Luckily, in the desert southwest, we don't have a lot of moisture, so I got a feeling that they're going to last quite a long time. Also, this outside box is not going to be somewhere where it can get wet. It's going to be on my back porch, which is covered. So unless there's a lot of wind-driven rain, it's never going to see moisture at all. So that's what we're going to try and use to start with, just because I have a bunch of this Cat6 cable laying around, and it's cheap. I can run over to Walmart and buy 25 feet of it for like $11. So we'll give it a try. If it doesn't work, then I'll go to something like a Molex connector and use sprinkler wire. Or better yet, something that's sealed from the elements. So I can always upgrade the design down the road. But I do want to be able to disconnect my 12-volt supply from the outside box if I know that it's going to storm. Simply because even though the triggering voltage is completely isolated from the SO239's, there's no direct connection, it's all done by relays. Still, the distance between the circuits inside the relay are not great. We're talking maybe 1/10 of an inch. And in a lightning strike, Lighting doesn't play by the rules. It'll jump 1/10 of an inch pretty easy. It'll jump 6 inches pretty easy. I've seen that happen. So I want to be able to unplug the 12-volt source from the box in the event that I know that it's going to storm, because remember, the primary consideration with lighting is you don't want it inside your house. So if you can avoid a run of either coax or cabling, rotor cabling applies to this too, inside your house and then back outside, that's a loop, and that loop is a conductor for high voltage electricity in the event of a lightning strike. So that's the upshot of that. So we got all the building pieces. This is finally cooled down now. So this will be my inside box. And my switches, I'll drill all the holes and put the switches in. And we'll go here in a row. And then the outside box is just going to be relays. I have these little circuit boards, and I bought some extremely cheap hardware from Walmart that I'm going to use for standoffs so I can elevate this inside the box. And I'm going to need 3 of these to elevate my relays up off the bottom of the board. And then I can solder to this and make all my connections. I'm going to be running coax inside the box. I have some RG-set 174 or something outside that I'll use to make all my connections to try and keep the inductive reactance to a minimum. But that's basically all there is to it. So much for part 1. This is just an intro in what I'm going to use and how I'm going to do it. Part 2, we'll start building the inside enclosure. Hey, thanks for watching.